WINDMAP stands for Weather Intelligent Navigation Data and Modeling for Aviation Planning. As the aviation paradigm shifts and we get more things like air taxis or urban air mobility, we need to have a better way to provide the operators with a safe environment. So one of the goals of the project is to actually measure and determine what the operating limits are of UAVs. Traditionally, weather measurements are done using towers, which are really close to the ground, or aircraft, which are really high up in the air. UAVs operate in kind of a unique altitude range called the atmospheric boundary layer. And that's a really windy, really turbulent environment where that interaction with the ground can make things really complex. The unmanned aerial vehicles are able to make measurements within this sort of range between towers and aircraft. This is going to give us more information about this atmospheric boundary layer that we can improve our modeling ability and our simulation ability so we can provide better predictions. In particular, what we were trying to do was look at how UAVs would respond to wind gusts. So Virginia Tech has a vertical gust generator, produces a controlled wind source that's in a specific direction. And we were flying different aircraft through that wind gust to see how they would each respond to the gust. And that's going to help us better identify the response to those airplanes and the safe flight regimes are for those aircraft. And we had to conduct these sorts of measurements over kind of a broad set of conditions. That meant we had to get up early in the morning, fly in the very calm, very quiet morning hours. And then over the course of the day, as the winds pick up, as the turbulence pick up, because the sun starts heating the ground, that creates thermals, that creates a lot of mixing, a lot of turbulence. And as that was occurring over the morning, we were then able to see how the dynamic background change was then affecting the flights through that gust generator. So WINDMAP has evolved from a multi-university research group. Initially was focusing on just how do we measure weather with uncrewed aerial systems. And now we have those systems down, we're able to perform some precise measurements with these systems. We want to start applying that to different problems, and WINDMAP is one of those areas. The aviation planning is one of those areas that we think we can provide a contribution with the uncrewed aerial systems. The main objective of WINDMAP is to provide operators who are working in sort of this new airspace environment, very close to the surface, the tools that they need to better operate their vehicles safely.